of these series of last one webinar for this series, the We Make, as part of the We Make project, which has been a collaboration between the Malta Chamber, the Malta Business Bureau, and the Energy and Water Agency. The intention of the session is meant to achieve a continuous level of engagement within the business community on aspects of energy and water conservation and efficiency. I think the war on Ukraine and the repercussions in terms of energy costs and the clear dependencies that still exist in terms of conventional energy generation might have shocked some stakeholders into action. And I would say that, coupled with the constant disturbing news about extreme weather situations resulting from the obvious climate change that I think nobody can deny at this stage, this purely puts more responsibility on all of us stakeholders to ensure that appropriate and consistent actions are taken. We would all hate to see sporadic action which dies down, after a number of years or sometimes even months. So the idea is to continue as different stakeholders that are represented here today. We cannot not remember as well the academia, who plays a very important part into this topic, both in the preparation of the students, who are our future leaders, but apart from that, as well from the research that they do together with the other stakeholders to ensure that the country, as well as the EU and the world, is properly prepared to face these challenges. It is very clear that we need to head towards more efficiency in terms of energy use, but also in the way that we use energy and water. And I think this webinar will make the last effort in this series to put this message through. As part of the manufacturing and other industries economic group, obviously, it is very important for us to make sure that success stories which leading companies in Malta have already implemented, and they are willing to continue working in this respect, are shared with those who maybe find it difficult to identify from where to start, and even maybe in terms of the funding questions that arise out of this topic. So without further ado, I think I can pass the microphone to the first presenter, and I wish you all a pleasant webinar.
Thank you very much, Ruben, for tying everything together and closing the project on such a positive note with a call to action, underlining the urgency that action is taken. Now, handing over to Ms. Kim Gatt, a student from MCAST, for the first presentation. Okay. Thanks, Kim. We can't see it.
Okay. So good morning. I am Kim Gatt, a student from MCAST. And my thesis was the development of intelligent robot hand for industrial automation applications. And I evaluated how a robot hand can be developed from a human hand and replace ultimately the operator. So throughout the presentation, I will be explaining roughly the introduction, the literature review, and the methodology used to achieve the final result. And then I will go through the testing glove design and the final and effective design. So just a brief introduction. With the current situation we are in, we are currently in Industry 4.0, where everything is interconnected together via the Internet of Things, and machines are all interrelated to each other, where anyone can connect to the machine and see what it is currently producing from anywhere around the factory, not necessarily by directly being physically there. But now we are moving to Industry 5.0, which is mass customization. And this requires manufacturing cells where you require more cobots that ultimately will aid to have mass customization, meaning that you can satisfy the customer needs, the variety of customer needs in a more broader aspect. And as you can see, this is a manufacturing cell where you have a robot that is currently maintaining the machines by feeding the material or else removing parts and tending the cell as much as possible. Therefore, this will reduce the repetitive tasks of the operator and increase the productivity of the overall system. So there are different types of grippers. There are the servoelectric, the magnetic, the jamming, the vacuum, and they are chosen based on what the robot is trying to manipulate. For example, if it is trying to manipulate a metal sheet, it will use magnetic grippers. And the literature review then focused on what are the repercussions of the operator doing repetitive tasks. If an operator is constantly exposed to the same part, doing the same pick and place for a long period of hours, you will enlist stress, repetition, fatigue, and other repercussions and other negative impacts on the operator. And apart from negative aspects on the personnel, it will also reflect on your production. When you have an operator that is working long hours on the same thing, he might not notice a mistake. For example, if he is checking if the color is good, there may be a part that has a defect and he does not see it immediately, and therefore end up having problems in the long run. So finding the defect, for example, in the next 5 steps, and that costs money to the production line. So to eliminate the operator, and by elimination, I mean that the operator will now be taught different aspects in the production rather than just being for a pick and place. He will now tend the robots and the cobots. The literature review then focused on the grasping of the hand, of the human hand. So the human hand was briefly studied, basically the main components, the main bones that make up the hand. And I had to remove one finger from the hand because for the testing glove, especially because it could not fit all 5 fingers. And to do so, I had to find papers and studies that said which fingers are less important than others. And by a study, as can be seen, the ulnar digits, meaning the little finger and the pinky finger, the little and the ring finger, can be removed, are the most important to the grasp, and therefore I concluded that we will remove the index finger because we assume that the index finger is the most important, and it is a good assumption because we are mostly using the ring finger, the index finger and the thumb finger. But the problem was with the gripper, since it was only in one direction, the pinky was important for the grasp. The pinky and the thumb plays an important part in the grasping position, and therefore the study and my perspective of the gripper, I decided to remove the index finger. So from this, I had to create, since I wanted to test the glove on several different people's total 9 participants, I wanted to have a broad spectrum of different hands, and therefore the glove had to be made adjustable to the personnel. Therefore, having kids try the glove, having elder, women, and a variety of people. And therefore, this is the design evolution to create a cover for the sensor that then can later be attached to the person's finger. So as you can see, in the top right corner, you have the FSR holder and the flex holder. You can see the images, or I removed this.
We can see them.
So I created the FSR holder, which is circled in yellow, and the other flex sensor holder circled in purple and blue. And as you can see, they are attached using flexible tie clips, which are all 3D printed. Whatever you are seeing in blue is 3D printed with Flex PLA. And the reason being is that this way decrease any injuries or any cuts that could be made to the person's finger. On the other side, the bottom left corner, you can see the one flex sensor and one force sensor attached to the Arduino development board in order to calibrate the sensors. So the next step was to create the circuit diagram to take readings from the participants and evaluate how much force each participant is making to grasp different parts, as well as the angle that each joint of the finger makes. And as you can see, there are a mix of force sensors and flex sensors. You have 2 flex sensors per finger and 1 force sensor for the tip. And the multiplexer was used to have only one input, but connected to several sensors. So these are the 3 main sensors that were used: the flex sensor to measure the angle, the force sensor to measure the force, and the ultrasonic sensor, which was used in a later stage to measure the distance. And this is a simple calibration that was done for the flex sensor. So a 3D printed chip was created to input the flex sensor in each slot, varying the angle and measuring different resistance and different voltage, which ultimately created an average for both resistance and voltage and plotted a graph. And a simple graph was plotted, so taking out the trend line, and from it, we could determine an equation that for each voltage read by the Arduino board, the respective angle based on this calibration graph was established. The same thing happened with the FSR sensor, but this time standard masses was used and a graph was plotted. So, but this time the X represents the mass. The ultrasonic sensor will be explained now, but used later. 2 ultrasonic sensors were used. They work with the principle of waves, and they reflect waves. And when the waves sort of bounce back from object, and they are transmitted back and received by the other by the same ultrasonic sensor, so you will send waves and get and receive them. That time taken is multiplied by 10 on 58, and it is inputted in the code to measure the distance. These are used to signal the motors to grasp and release a part. These are the participants testing. So as you can see, there are a variety of ages for the 9 participants, and those are the 3 main basic positions that the persons were asked to make: the flat one, the 90-degree bend, and the total fist. It was a reference point for each participant. The image on the left shows the 6 parts that were asked by the participants to be grasped, and these were given by Metals Electronics, therefore from an official production line. And you can see the participants grasping the part. The data retrieved was analyzed, and the various tables were created to ultimately see the maximum and minimum joint benditure sort of. And the first table shows which which fingers were used by part, and wherever you see highlighted in red means that finger was not used for that part by that particular participant. And as you can see, the smaller the part gets, for example, in part 5 and part 6, the pinky and the ring was never used. The other table is a more detailed data per part, and the most important and the last three columns where they are giving the maximum and the minimum value of each force of each sensor out of all the 9 participants per part. And this data was extrapolated and made in a simpler table where you only have the maximum and minimum values of each sensor. Apart from that, I also required the maximum joint, the maximum band by each joint, and this was only sort of managed to get this information from the initial 3 positions. The maximum fist position, the fist position is maximum bend. The knuckles and the other joints can be bent, and therefore they are listed here. And this was used to ultimately size the pulleys and the servo motors. So the first sensors were used to size the servo motors used, whilst the maximum bend angle was used to size the pulleys. And then the design process of the actual hand was started. So basically, just in a summary, each finger first consisted of 3 parts. You have the tip, shown in green, and the blue part. They are connected together, and the fourth sensor is affixed in the middle. They are then joined with another 2 parts, part 3 and 4, and which ultimately form the final finger. But along the way, these were changed because instead of static idlers, I used pulleys. And in fact, as you can see, they were changed. Parts 3 and 4 were connected together with a space left in the middle for the pulley to be fixed. This is the design process of a Fab 2. A calculation was required. I did not mention it here because it's quite a long calculation where I had to size pulley according to the angle of each joint. And if I followed the calculation properly, the hand had to have a similar size to this. But the problem was that the calculation was based on a paper, and they had a 3-jaw gripper, but with 3 joints per finger. And therefore, since it was different, this is the shape that we ended up with. Therefore, I had to modify it a bit, use the same pulleys, and modify the structure to have the same function, to have the pulleys work in the way I want them to work, and but have the shape of the human hand. And ultimately, this is the design of the prototype 3. So we have the pulleys, and beneath the pulleys shown in yellow squares, a depth was left for the pulley to rotate freely. And as you can see, that is the final hand designed with 4 fingers and two pulleys each finger, or 3, depending whether it is the thumb or the other fingers. These are the servo motors. So a simple calculation was created to see the amount of force and ultimately the torque required by each finger, and a holder for all 4 servo motors, 1 per finger, was designed to directly direct the strings to each servo motor without interfering each other. This is the final design. The end effector, so you have the palm in the first image. The second image shows the wrist where the servo holders will be affixed inside, and the final CAD drawing assembled with the wrist and with the servo holders and with the palm. This is the final circuit diagram used with the 2 ultrasonic sensors, the 4 sensors, 1 per finger, and the 4 servo motors. And as you can see, the ultrasonic sensors are affixed, 1 with the wrist and 1 with the palm. And the reason being is that the hand will work by being attached to a cobweb, and whenever the palm sensor will read a particular distance, it will signal the motors to grasp, and whenever the other sensor, the one at the wrist, will sense a smaller distance, it will release the part. So it is a pick and place from a higher to a lower surface. And the other image shows all the wirings inside the wrist. This is the testing phase where this was connected to the cobot, and this is the testing of the gripper. So this is all, and if you have any questions, please ask.
Thank you very much, Kim. I was blown away by the creative process which went into it, even the 3D printing for parts.
Thank you.
What's next? Do you have any plans?
Yes, I have been accepted to continue my master's in Cranfield and in the UK.
Congratulations.
But thank you. I will specialize in the design of aircraft.
Fantastic. Thank you for taking the time. I know that you're at work today, but you've made time to be with us, so extra appreciated.
Thank you. That's all from my side.
Excellent. Excellent. We will let you get back to work then, Kim. Congratulations, and we all wish you the very best.
Thanks a lot. Thank you. Have a nice day.
Well done. Icon, another student from MCAST. It's your turn.
Okay.
Very good.
So good morning, everyone. I'm Aiken Dazira from the Institute of Engineering and Transport at MCAST, and my dissertation is regards the study of the designing and an improvement in the versatility of an already existing PET printing machine at a local production company. These were the contents that were followed throughout my dissertation and this presentation. Starting off with the problem definition, mainly there were three. First off was that the existing PET printing machine was printing only 3 colors, where the demand for 3 colored products was totally obsolete. Also, there was a lack of versatility and functionality within this PET printing machine, having to produce only one set of products, and having these two problems amalgamated together, another problem arises, that unutilized production area of floor space. Starting off with the modifications performed were the removal of the vibrating bowl feeding system in order to make space for the fourth PET printing machine, the removal of the outfeed conveying system, where an ergonomic setting for the operator to work within the machine was to be made. A cutout from the base of the vibrating bowl feeding system was to be performed from the material in order to utilize all the possible material from the original layout. A cutout that I mentioned previously was to be performed from the front end of the machine in order to have 3 jigs available for the operator to work with, which was a company standard and a requirement. Within the inward modification of the layout, operator guards have to be amalgamated as well within the machine in order to prevent any injuries. And lastly, the human machine interface has to be shifted towards the right-hand side of the machine in order to incorporate it within the machine, and for the operator also to work freely with it. Moving on was to produce a product design specification with the company itself, where such PDS incorporated the product identification. Basically, it's what the machine will be used for, its key performance targets, which were discussed with both the company and the tutor at MCAST as well, and the service environment it will be working in, and the user training required for the personnel. The market identification which was basically the department that the machine will be situated at. Some key project deadlines that were discussed with both the company especially, and also with MCAST in order for me to keep up with the scholastic deadlines. Some physical descriptions that were required from the company, especially where there was an allocated space that must be utilized in order for the machine to be situated at, and all the material that was needed for this modification to be performed. Some financial requirements were also discussed, where a maximum of 15,000 euros were to be applied from the internal investment fund of the company, which was a pretty tight budget. Hence, a cost center through an ERP system of the company itself, being SAP, was performed in order to track all the work being done on the machine in order for the punching of personnel and all the parts that were gathered from the mechanical stores. Some social, political, and legal requirements were also discussed with the company, where especially legal requirements were discussed also with external verification bodies in order to comply with all the EU standards. Some manufacturing specifications were also discussed in terms of suppliers that were needed, either internally and externally, and the machines and skills needed for this project to be done. From the PDS, then a project mind map was performed, where important factors were gathered in a visual manner in order for us to visualize the project better, starting off with the fact that the company requested 4 printing heads. It must be also manually operated, where the vibrating bowl feeding system was removed. A quicker changeover had to be acquired quicker, an increase in its versatility and functionality, the development of the mechanical designs, some safety and ergonomics that must be incorporated within the design, and finally a machine work instruction had to be developed in order for the personnel working on the machine to know better all the stuff that must be held. Moving on to the machine layout sketches, I started off with a rough sketch in order for us to visualize better all the project and all the procedures that must be taken into consideration throughout the whole process. And such design was then developed onto a CAD software, where for us to do some changes, it would be easier for us. In fact, it was agreed that the area marked in yellow will be cut out as shown, which will make a more ergonomic design for the personnel attending the machine. Moving on to the next part was a declaration of conformity, which is a legal document that must be signed by an authorized body for the project to be compliant with all the EU regulations. Hence, some directives and standards had to be followed from our end of the design of the project, being those 5 listed. And the next step was the project modification procedure, starting off with the base, where, as discussed, in order to keep up with the budget cap we have, all the sufficient material that could be used was used again. Hence, the standard framing on the bottom was totally reused from the old machinery layout. The area marked in blue, the only modification was performed is the cutout shown on the front, where the operator will be situated at, and on the other hand of the design marked in green was the platform for the 4th PET printing head, as mentioned earlier. The next step was the top framing of the machine marked in green, and also some safety panels marked in blue in order to prevent any risk of injury from any personnel attending the machine. Lastly, in order to secure all the opening of the machine, where the safety guards marked in green, where they were performed in such way that the machine will be totally enclosed, and also if any service or breakdowns arise, there is still access to the inside of the machine. A project modification procedure was a standard base clamp also, where in order to acquire a quicker changeover, a study on all the setup procedure was performed, where the 3 steps highlighted were the 3 steps that were kind of can be eliminated or reduced in terms of timing, where through the study a design on the top left was performed through prototypes of using 3D printing as well, and as could be seen in the picture, these jigs are to be situated on top of the rotating table of the machine, where with such design, the machine can run various amount of products, and also tackling the changeover problem, where from 13 steps it was reduced to 12 steps, and with an introduction of a quick release system on these base clamps, a reduction of 32 bolts was reduced on all the changeover, which resulted in an amount of time that was reduced from the changeover. Lastly, the operator guards were designed using the Siemens hinge switch, which triggers at an angle of 10 degrees of movement, which eliminates the possibility of the personnel to reach inside the moving mechanisms of the machinery. This left us with the final assembly of the project, which led us to on the left hand side was the old machinery layout, and on the right hand side is the new proposed layout of such project. Some machine performance studies were also performed through a time study layout of the company, where the client's demands were initially those of 1,200 cycles per hour on a 2-print parameter setting, and the machine's maximum capacity was that of 1,440 prints per cycles per hour on 2-print parameter setting, as shown in the red circle. The return on investment was then studied, which was that of 2 to 3 months return on investment, which is basically calculated on 3 factors, being the hours recovered of the system, the assumed utilization, and the margin hours based on sample for the production. Also, such project was done after a cost-benefit analysis was performed, where 2 possibilities were met, being that the purchasing of a new machinery or modifying the existing machinery, where purchasing a new machine would cost around 400,000 euros, where the modification cost us 14,000 euros. And if the company would have opted for a new machinery and disposing the old one in order to make space for the new machinery, the machine disposal costs have to be considered. And when it comes to the overhead costs, preventive maintenance, and the replacement of components, if the company would have bought a new machine and kept the old machine in-house, the cost would be for both the machines, whereas the modification of this machine would let us to for when it comes to overhead costs, preventive maintenance, and the replacements of components for only one machine. As per safety considerations, in order to comply with the EU regulations, a risk assessment was performed by an external body in order for the assessment not to be biased, and also a work instruction was performed. I would like to thank you all for your attendance and attention. And if you have any questions, please ask.
Well done. I'm really impressed because you did this with a company. Is it private? Asking which company it was?
It is, yes, because there was a non-disclosure agreement.
Okay.
Even when it comes to the risk assessment, I couldn't show the risk assessment publicly, even the work instruction.
Yes.
Yes, it is private, yes.
No problem, no problem. Was just curious. In any case, it's
Okay.
fantastic seeing you identify a problem, exceed expectations, and tackle the problem in such a holistic manner, from health and safety to cost-benefit analysis, etc. So fantastic work, a fantastic project.
Thank you.
If we don't have any other questions, we can move now to Ms. Rebecca Clark, a student from the University of Malta. Aiken, thanks again for your time.
Thank you, everyone. Good day.
And well done.
Thank you.
So let me share my presentation. Okay. So good morning, everyone. My name is Rebecca Clark, and I'm a PhD student with the University of Malta. And for today, I'll be presenting a paper which I'm working on and will soon submit for publishing. It's called Towards a Sustainable Injection Molding Using Printed Conformal Cooling Channels, a Comparative Simulation Study. Now, before I explain what exactly that means, I'll go through the outline just a bit. I'll be going over the motivation behind why we chose to do this study, the materials and methods, simulation, results and discussion, and then closing and questions. So let's start off with why we were tackling the issue with sustainability in injection molding. In EU in 2020 alone, 57.2 million tons of plastic products were produced. And of those, the most used process is injection molding, and it is also the most energy intensive process of all the plastic product producing processes. The injection molding cycle consists of various different phases, from mold opening to closing. However, the longest part by far is the cooling phase, which takes up around 65% of the cycle time of injection molding typically. Therefore, current research focuses a lot on the cooling of injection molding. In fact, the cooling phase has a very significant role in injection molding. It affects both the quality of the part produced and also the cycle time. Therefore, by making the cooling phase more effective and efficient, you are reducing the overall cost and energy usage of the process. Now, in the cooling phase of injection molding, there are two mechanisms of heat transfer, namely conduction and convection. The convection part of the heat transfer in the cooling phase is taken up by the cooling channels which are drilled into a mold. Basically, when cooling a mold, coolant, most often water, is pumped through channels which are produced inside the mold. And on the other hand, conduction is taken up by both the coolant as well as the mold material surrounding the part. Now, let's look a bit at cooling channels. Originally, conventional cooling channels were used. Conventional cooling channels are channels which are drilled straight into the mold. And given the limitations of drilling, they can only form straight lines in terms of their designs. And these are two examples of what it looks like. The issue with conventional cooling channels is that there isn't an equal distance between the surface of the plastic part being produced and the center of the cooling channel. And this is especially evident in the picture of the helmet, which I have produced on this slide. What does this lack of uniform distance mean? Basically, you get defects in parts, such as warped sides and also sink marks, which are a bit like pits in the part produced. And these can have detrimental effects on both the functionality of the part and the aesthetics of the part. On the other hand, with the advent of 3D printing, so came the advent of what are known as conformal cooling channels. Conformal cooling channels are channels which adhere to the geometry of the part. They follow the contours of the part. And therefore, you are significantly improving the uniformity of the distance between the cooling channel and the surface of the plastic part. Here's an example of what the use of conformal cooling channels produces. In here, I used an example from literature where the researcher attempted to mimic the design of the human blood vessels with their cooling channel design. And this research resulted in a 13.7% reduction in cycle time and an 82.5% reduction in the average temperature of the part after ejection. So, in this study, what are we trying to do? What we are trying to do is to study the effect of thermal conductivity of the mold insert material, meaning the material surrounding the plastic part being produced, on the effectiveness and efficiency of the cooling phase of the injection molding cycle. So basically, what I'm trying to do is seeing how the thermal conductivity of the metal surrounding the plastic part being produced affects the overall conduction part of the cooling phase. For this, I had to create a case study part, and I created it specifically with problems in terms of uniform cooling. I made it very difficult to cool using normal cooling channels. And in fact, I included certain difficult to cool features, such as the rounded sides and the long vents. And then on the other side, we've got a thick rib at the bottom and walls within the core to reduce the overall space available for cooling channels. I also had to design various cooling channels. These are the conventional cooling channel designs, and they range from very simple lines to more of a square pattern. And then we've got the conformal cooling channel designs, one of which is a U-shaped cooling channel, and the other is more of a 3D zigzag pattern. As you may have realized, with the conformal cooling channels, I can cool the core of the part. They're shown in the center. I'm not sure if you can see my mouse, but these are the core cooling channels. While with the conventional cooling channels, that's not possible at all. So moving on, mold material selection. I had to, in order to test the effect of thermal conductivity, I had to select materials of various thermal conductivities. And therefore, also, I'm looking at this study from a sustainability point of view. So not only does the thermal conductivity of the material affect the overall feasibility of the material, but also the price. And also, given that conformal cooling channels must be 3D printed, the materials have to be available in powder form for a 3D printing process called LPBF. The resulting materials selected are the following four, one of which is a 420 stainless steel used as a control material because it is very cheap, lowest thermal conductivity, and very commonly used in industry as a mold material. Another tool steel, followed by an aluminium alloy and a copper alloy. The prices and the thermal conductivity significantly range. However, the highest thermal conductivity is the copper alloy, followed by the aluminium alloy. An important aspect in terms of mold materials is how long the mold can last, meaning how many cycles can you do with the mold before it starts to crack and break. Unfortunately, the process of determining the life expectancy of a mold is very complex, and there is a very large number of factors involved. Therefore, it is not possible to predict the life expectancy very accurately of a mold material unless you conduct physical experiments. However, this study is simulative in nature, so we made use of what are known as the SPI standards, which by using the hardness of the material, you can predict the maximum number of cycles very roughly that a mold material can last. Naturally, the material's properties and prices change when bought in powder or in bulk form. And this is just a look at how different the prices are. Because while copper in bulk form costs €5.47 per kilogram, in powder it costs €95 per kilogram. So this significant increase in price is also considered. So simulation. I inputted the data of the materials into the simulation and also conducted meshing, and this is what the results look like. This is just an example so that you have an idea of what I look at. And here is a summary of the overall data. Over here, we're looking at a graph of cooling time versus thermal conductivity, and the pattern is very interesting. First of all, one trend that we noticed immediately is that the effect of thermal conductivity is much more significant in the simple cooling channel designs. The red and orange lines are the conventional cooling channels, those which have straight lines. Basically, one of the reasons behind this could be that with conformal cooling channels, more material is cut away to make more holes. And for this reason, there is less metal material to conduct heat away. Furthermore, another interesting point is that at the point of aluminium, it's tagged at the bottom of the graph. Beyond that point, the increase in complexity of cooling channel, along with any increase in thermal conductivity, seems to have little to no effect on the overall cooling time. A very similar trend is seen on the maximum average temperature of the part. The maximum average temperature refers to the temperature of the part at ejection. It is very similar. There is an especially steep decrease in maximum average temperature for the simpler cooling channel designs. And there is less of a convergence at aluminium, but there's still somewhat of a convergence of points. And also, when you talk about quality, you cannot forget, when you talk about sustainability, you cannot forget quality, as the quality of the part is very important. As can be seen in this graph, the cooling channel design and the thermal conductivity both had very little effect on the overall quality of the part. In fact, I believe the greatest discrepancy in quality was around 0.046 of a millimeter. So very little changes in quality. Here is a bit of a summary of the cycle time reduction. I converted the cooling time reduction into cycle time reduction. And again, it is very evident that as the complexity of the cooling channel design increased, the effectiveness of thermal conductivity decreased. Now, we also attempted to gauge the increase in material costs for alternative material molds in comparison with the decrease in electricity costs in Malta. What we did here was we made use of the specific energy of the injection molding process and applied the cycle time reduction to the overall energy of the process. In this case, we took 1 million of my case study parts as a case study scenario. And as can be seen in the table, the increase in mold material costs is relatively low for the conventional cooling channels, and the decrease in electricity costs using higher thermal conductivity materials decreases significantly. So looking purely at the increase in mold insert costs and the decrease in electricity costs, it is worth it to make use of alternative materials for the basic and square conventional cooling channels, but not worth it for the conformal cooling channels. However, this table only considers two factors: the mold material costs and the decrease in the electricity cost. While on the other hand, there are many other factors to consider. But other benefits, in fact, of cycle time reduction are a decrease in lead time, a decrease in man hours, and a decrease in storage costs for work in progress batches, while also an increase in customer satisfaction and an increase in productivity. Concluding remarks, in reality, this study that I performed is simply a benchmark for my future study, which will include the development of a new type of conformal cooling channel. And based on these results, I've decided that I will be using 420 stainless steel in my future study because I will plan to create very complex conformal cooling channels, and therefore the increase in thermal conductivity should have very little effect on the overall cooling time. Before I conclude, I'd just like to pass on my thanks to Drake and the EU who are funding my project. Thank you very much, and if you have any questions, please do ask me.
Thank you, Rebecca. It's exciting to see a project that has such potential to be scaled up and cause such savings across industry. So you're really working on sustainability at the core of the problem.
Thank you.
What's next for you, Rebecca? You're publishing this paper?
Yes, by the end of August, I need to submit my paper and hopefully it gets accepted for publishing. My next steps are to begin developing the novel conformal cooling channels. Unfortunately, I cannot really share the details about these channels yet because they are, it's a bit of confidential information. However, I hope to be able to present my initial designs and simulations next April or May, something like that.
You have to keep an eye out then.
Yes,
Thank you very much, Rebecca. I'm
Thank
glad
you
we
very
got your perspective from
Thank you.
University of Malta as well.
thank you very much.
Okay. Mr. Stefan Roll from MCAST.
Hello, hi. So I'll just share my screen. Okay. So is that okay? Can everyone see that?
Yes, thank you.
Okay, so basically what I'm going to be presenting today is this is the second chapter of my PhD. I'm currently a lecturer, but first a little bit about me before I start. I graduated in 2012 in electrical and electronics engineering from the University of Malta. And a year later, I completed an MSc in bioengineering at Imperial College London. And in 2017, I started my PhD. And I still have to finish my PhD. So I'm ending in September, hopefully. Hopefully, I'll have my Viva date then. And we'll see how that goes. Apart from all of this, I'm currently employed as a lecturer with MCAST in the Electrical and Electronics department. And as my role in a lecturer, I'm also involved in a lot of collaborations with industry and projects related to this. So currently 2 projects that we have funding for is the Intelligent Inventory project. And this is a project with Methode. So basically, I'm mostly based on data analysis and AI, artificial intelligence and machine learning. And companies such as Methode, for example, they approached us with some problems and we got external funding. And these are just some of the partners that I work with. So we got funding for Intelligent Inventory through MDIA, the Malta Digital Innovation Authority. And this project involves basically we're making predictions for their supply chain. As you know, COVID caused great disruptions in the supply chain, and Methode was not immune to this. So we're using external data that Methodes gather from real world data that affects their suppliers, and we're making predictions on how that data actually will affect Methode, so that Methode can plan before these catastrophes affect their supply, right? And that's the Intelligent Inventory one. We're also looking into AI and in helping students complete their dissertations, and that's the STAR project. So this has Fusion R&I research excellence funding, and we're basically creating, if you want to put it short, some ChatGPT, but very reliable, and only something that only produces good sources, and hopefully sources that are in line with a student's way of learning. Okay, so it's something that would be great, hopefully, for even training in the future. You could there are also industrial applications to that, where if you can train your staff with these kinds of tools. But anyway, enough about myself. I'm going to speak a bit about the second chapter of my doctorate. It's basically what I'm doing is localization for autonomous vehicles. So I have a very strange history over there. So I started out electrical and electronics, ended up in bioengineering, and now I'm doing a PhD in autonomous vehicles, but most of my projects involve AI. So what is the tying factor in all of these things? Well, artificial intelligence is actually an element of each one of these, and machine learning specifically of artificial intelligence. And that's kind of where the craze is nowadays, funnily enough. So I'm sure you've heard a lot about this. So in the autonomous vehicle section, what I'm trying to, in my PhD, I'm trying to localize a vehicle. And the first question you might ask is, why are we localizing vehicles visually? Like, what's the point? Don't we have global navigation satellite systems for that, like GPS or GLONASS or whatever, right? Or Beidou. So there are some issues when we try and adapt GNSS systems for autonomous vehicles. So if you're trying to operate, it works very well in aviation and the maritime sector, but if you're trying to adapt these systems to vehicles, you're going to start running into these problems, basically multi-path errors and line of sight being blocked from satellites. What this results in your GNSS giving very weird readings when you're in urban environments. If you ever go into a city and you're next to some high-rise buildings and you take out your mobile phone and you try and see where you are on a map, it's going to give you like this really large circle because it won't be sure where you're taking your readings from, right? And this is because of reflections on these high-rise buildings, right? So we can't just rely on GNSS, we need to also rely on other means, and visually is something that us humans do very well. We know where we are because we can look around, see the buildings around us and decide where we are based on that. But also GNSS isn't very good in underground areas. So if you have any kind of tunnels or parking lots or anything of the sort, you're not going to get a GNSS signal, and that's going to be a bit of a problem. So next we're going to ask, how can we do this? So how would you go about localizing visually? And the best way probably, right, would be if I'm driving down the road and I have a camera, like an image being captured from my vehicle. Maybe if I do a relatively easy image search, I can find an image in a database that looks kind of identical to the image that I'm seeing. And that image in a database would have some kind of global coordinates attached to it or some kind of coordinate to it. And I can take that coordinate as my own coordinate, right? Because I found the same image, I'm seeing the same place. However, unfortunately, this doesn't really work in real life, because in real life, the place is going to change. And this is where AI is going to enter into this study over here, because as you can see, we have the street in this case, it's the exact same place. And as humans, we're capable of understanding that these two images are captured from the same place, but this is a very difficult task for a computer to do. Literature proposes many methods, and in my study, I proposed in this chapter, basically, I proposed an end-to-end approach. And when we speak about end-to-end approach, what we say in artificial intelligence, end-to-end is when you take a task and you basically train a model to tackle this task from the beginning all the way to the end, right? You don't kind of use your model for a part of it and then take the output and do something with that output, right? So it's basically from the beginning to the end, everything goes into the AI, and the AI will then just present some kind of result. These are basically, I'm not going to go into a lot of detail because of time, but these are the two models that I developed, basically. The end-to-end is the one on the left. You can see if I can put a laser pointer here. Can you see that, hopefully? So this over here is the end-to-end, and this one over here is the metric learning. Very quickly, how they work. So we can put in two images in this case. If they're from the same place, I want my end-to-end model over here to tell me that they're from the same place. So this can be a binary output, right? Same place, not same place. So that's our end-to-end model. And the metric learning is a little bit different. We apply the same image to a separate model. This is the same model, but we apply it twice. And for each image, we're going to get some kind of, this is an output vector, which is basically a group of numbers. You can imagine it that way. And it's a dimensionality reduction technique. So we start out with high dimensional information, which is an image, and we end up with a lower dimensional information, which is this smaller vector. And then instead of comparing the images to see whether the images are the same, we can compare the vectors to see whether they're the same. And hopefully these vectors will still contain the information which is intrinsic, which is important for localization. So as I'm saying, this aim of the experiment is to try out our suggested method, this end-to-end approach, versus the method most commonly used in literature, which is this metric learning method where you compare the vectors at the end. So how are you going to go about and do this? Well, I started out collecting a simulated data set. So generally speaking, whenever we're doing studies of these kinds, we try to simulate before we just implement, so that we see that our ideas have some kind of base in reality, right? We're not going to go out and collect an expensive data set when our simulation results would be terrible. But we'll collect the real data set afterwards. So I collected a simulated data set. This is using the Carla simulator. It's an autonomous driving, it's a vehicle simulator developed by Intel. It's open source as well, so anyone can use it. So we collected images like the one over here, the ones over here. These two are not taken from the same place. We're going to start pairing up the images then, images not from the same place and images from the same place, like these two over here. And then we're going to be feeding them into a model which has been trained specifically to be able to identify whether they're from the same place or not. So this is the methodology, a bit more in depth. I can explain at the end if you have any questions, but more or less the idea is this. So if I have two images, same place, output of my end-to-end will be 1. 2 images not of the same place, the output ends up being a 0. Okay. So just some specifics, we use binary cross entropy to train our models on this data. And when it comes to the metric learning, we have to use different ways of training because it's a completely different field. So we use contrastive learning instead and triplet loss training. Once again, I won't go into the specifics of these. However, what they're doing, it's always making these vectors similar if they're from the same, if the images are from the same place. Both of these approaches are making the vectors further away. They're pushing the numbers away if they're not from the same place, because we want to distinguish between them. So, oops, I went back. So basically, we end up with results from the simulated data. And as you can see, our binary cross entropy end-to-end method over here performed the best. Now I say the best, this over here is a precision recall curve. Without going into too much detail of how this works, basically you want the score which comes closest to this corner up here is basically the better one. It's a way of representing our data. And as you can see, our end-to-end method seemed to perform the best on simulated. And that meant that going into real-world testing, we wanted to make sure, we wanted to proceed with testing to see whether we actually are onto something or whether the results on the simulated data set was some kind of fluke. So we headed out and started collecting a real-world data set. And as you can see over here, for example, are 2 images captured from the same place under different weather conditions. So we have something at night. I think this was at around 8 p.m. and this is in the morning. And these two are once again an overcast kind of condition and a sunny kind of condition. And we want to tell our model that these two are the same place and these two are the same place, and they need to now be capable of detecting the same thing, but in real life, right? And once again, we tested it out, and our results show that the end-to-end method outperformed the contrastive and triplet loss method, the metric learning methods, basically. And this is something quite big because practically most research make use of metric learning, and they haven't tackled this in an end-to-end fashion. And we're just showing that, listen, all the work that you've done, kind of, you can do it a little bit better, right? At what significantly better, basically. But you might be wondering, why are the results in this case so far from the simulated? Because the simulated, most of the results approach the optimal point here, which is 1-1. But you can see that they're quite far off from that optimal point over there in the real world data. But this is mostly because of issues when collecting the data from the vehicle. So for example, we're matching places based on the GNSS locations. However, GNSS updates on most consumer units every 1 second. And if you're driving a car at only 40 kilometers an hour, within that 1 second, you're going to traverse around 11 meters. What that means is that you're going to have, even if they have the same GNSS coordinate, these two images, they're not really captured from the same place. So our models are capable of overcoming this limitation as well, and still working even though our data isn't exactly pristine. So that's basically our conclusion. Our conclusion from the study, basically, our end-to-end approach seemed to be better than our metric learning approach. It achieved higher F1 scores, which is the metric we use to compare the methods. And we published this work last year at the IEEE Intelligent Vehicle Symposium. If you're interested in the paper, there's the QR code over there. So if you have any questions or are interested in any form of collaboration, I'm currently working at MCAST as a lecturer, and I'm very interested in any kind of AI projects, especially AI projects with industry. And if you have any ideas, you can approach me, contact me on that email, and we can set something up. Thanks for your time. If you have any questions, go ahead.
Thanks, Stefan. Let me start by pointing out the good news that your red laser worked throughout the presentation.
Brilliant. I love that.
That's some good news to get off the ground. It was great hearing a bit more about AI in business, because obviously, as you said yourself, that's one of the next big things. I'm sure your presentation will be of particular interest to the Sustainable Mobility Committee at the Chamber of Commerce. So I will make them aware of your excellent work.
Thank you.
Will there be any kind of research you think happening in Malta at any point in this regard?
So,
of course, Malta has got its own peculiarities.
Yes, of course. So this is actually, so by research, you mean a continuation of this?
Yes.
So currently, we're publishing another paper, which is still on the same data set, but however, we've made modifications to the model, which is now actually looking into semantic meaning. So what do I mean by semantic meaning? When you're looking at certain problems, such as localization, there's some things are going to be relevant to your location and some things aren't going to be relevant. And as human beings, we know this, right? So if you have a vehicle in front of you, you know, the car isn't really telling you anything about where you are in the world. It's just someone's car. He parked it there. It won't be there the following day. So that car isn't telling me where I am at, right? So we're using now semantic information within the model. We're detecting things like cars, and pedestrians, and we're saying these things have nothing to do with our localization, and we're excluding them. So we're kind of improving our model without any additional data. We kept the exact same data, and we've actually obtained better results, and we'll be publishing that very soon.
Fantastic. Looking forward to it. Thanks, Stefan. I think we have just enough time now to move to the last presentation, which is from Mr. Stephen Sammut, who's a director at MCAST, who will speak now more generally about possible collaboration between business and MCAST.
Thank you. I will share my screen. I believe you should be seeing my screen.
All clear. Thank you, Mr. Sammut.
Thank you. So as an institute, we're representing the Institute of Engineering and Transport of MCAST, and the students and Stefan, who were speaking before me, all hail from the same institute. We are one of 6 institutes at MCAST because there are other areas which are covered by other institutes, such as business and applied sciences and other fields. So basically, as an institute, we are made up of 6 departments, namely the Mechanical Engineering Department, Aviation, Maintenance and Operations Department, the Maritime Center, Automotive Engineering, Building and Construction, and Electrical and Electronics. Each department focuses on his main point of convergence, we can say. However, the departments then work together to deliver programs which are holistically aimed at the sector, which is becoming more interdependent as we speak. I mean, today you don't see any mechanical technicians or electronics technicians who are purely in that field, but there is a lot of interdependence and interoperational ability between the sectors. So each department basically would deliver programs between level 1 and 7. Level 1 would be students who have basic literacy skill issues and also are learning the basics of their vocational competences. Level 7 would be more the master programs, of which we have both taught programs and mastered by research. Mechanical engineering basically goes into two main areas, which are the manufacturing engineering and the plant, which is the operations and maintenance engineering. For the manufacturing and also the plant, we have different machinery. You can see some photos here of our machinery. So you can see CNC milling machines, lathes. We also have injection molding machines and various other systems, including, of course, materials, laboratories, such as which we can conduct tensile testing, hardness testing, polishing of grain structures and analyzing them. We are also investing in additive manufacturing, which is, of course, nowadays becoming more and more important. Now, links with industry in this department, how can they be brought forward? So basically, we have, I think, three main modes of or four main modes of collaboration with industry in the lower levels, level 3 and 4, which would be the technical level 4, and the assistant technician level would be apprenticeship. So our students basically conduct apprenticeship with industry. This is a very important mode of collaboration where our students basically would be, let's say, 3 days a week at the college and twice a week then at the place of employment. And this gives them a holistic training perspective, not only in the technical area, but also in the way they should interact with their colleagues and work as a team and many, many other things. Then in the level, of course, the degree, the bachelor would see collaboration, for example, in the case of dissertations. I mean, you've seen some of our dissertations, one of which, for example, was being done in collaboration with industry. This is just a sample. We have many more. I mean, most of our dissertations are actually being done in collaboration with industry, whereby industry is gaining because it is learning from the students' research, and the student is having a real life case study rather than doing just desk studies or lab studies, which ultimately are then filed away or whatever. We also have then internship in the degree, and also we have collaboration with the lecturers, where the lecturers basically also conduct research themselves, such as Stefan. Stefan is one of our lecturers, for example, which can be linked with industry. So this is some of the collaboration we see. This, not only this, but other departments too. Here you're seeing some of the photos from the manufacturing department. So you can see automated production systems, which we are setting up also and enhancing in view of Industry 4.0 and now even 5.0. So basically we're having a lot of work in the automation fields. As you know, Industry in Malta, at least let's say industry which is aiming to continue in its sustainability, is aiming towards more and more automation and more robotic systems being put into the manufacturing sector. Which we're even seeing robots now in the service sector, but the manufacturing is, of course, the one which uses them most. And here you are seeing, these are all shots from our institute workshops. So you're seeing, for example, here, trainers, which students use for electropneumatics, electrohydraulics, PLCs, microcontrollers, and many, many other things. This is a workshop then which is used by the plant engineering. So here you're seeing a fully operational gas turbine, for example, which students can learn about the parameters of operating a gas turbine, inlet temperatures, outlet, compression ratios, and many other things. Wind tunnel facilities, compressors, refrigeration. This is just part of it. We have 3 labs in refrigeration, conventional machining. And here also is something we can collaborate with industry when it comes to upskilling. So industry also can basically get in touch with us, or we get in touch with them, and we can upskill the workforce which is currently at the place of work. So for example, we can provide specialized training in the use of machining or welding or other things, electrical, I don't know, controllers, electronics. So we can give specialized training to industry, to the technicians, to upskill the workforce and make them more competent. An advantage, of course, is also that our certification would be level rated, which means that the certification given by MCAST would have currency for the students doing that particular course, even out of their place of work, and therefore the training would be more attractive for students to join such training. Electrical and electronics department, here we basically have the divide between the electrical power and the electronic side. So with regards to electrical power, of course, we have the full set of programs from the authorization A and B for the wireman to courses on photovoltaics, of course, degree in electrical engineering. But also then we have the electronics field, which is basically goes into the sectors of computer engineering, industrial engineering, automation, microcontrollers, robotics, biomedical engineering, and telecommunications. And here again, you're seeing some of the students working here, and some of the workshops we have. Actually, some of the facilities are also set up by industry. Here we're seeing a particular facility set up by the MATS. MATS is the Malta Air Traffic Services, because here we train the technicians and the professional people who then go to operate the network of the MATS, the radar systems and many other things. So fiber optics, communications, control engineering is very important, where we come to PLC control, HMIs, robotic systems. Many of them are built in-house actually. Electrical power, here we're seeing an 11 kV switchgear, motors. Motor drives are of course gaining in their importance because of electric motors and electric cars, sorry. Installations. We have also courses which are focusing on robotics, very important for industry. Drones are gaining in importance. We also had some particular research project using drones for crops, for example, and crop analysis. So we also work in conjunction with the agricultural sector, for example, and the maritime sector for pollution control. And of course, AI nowadays is very important, as also mentioned by some of my colleagues, and is being integrated in many fields. And here you have the various specializations we have in this department. As I mentioned before, as an institute, just to give you an idea, we have around 250 lecturers, academics, and we have around 1,300 full-time students, part-time students, and we have many more because we have, as I mentioned, bespoke courses with industry and part-time evening students, because we offer many of our courses, including the degrees, in evening mode. And here is another important point for industry, because, for example, if you would like to upskill your workforce, they can even come for evening courses, or we can do the courses at the place of work, which means that a student would continue working while upskilling himself. Automotive engineering is becoming very important, also electric vehicles, and we are looking now into hydrogen for transportation, which will be another game changer, in my opinion, much more than electrical vehicles. We have spray painting, automotive repair, also when it comes to buses, light vehicles. Then we have the aviation center. Here again, we offer courses which are related to either the operational side, flight operations, or else maintenance. So we basically train all the people who go to work at the MROs, Lufthansa, SRT, Medavia, but also people who work in the operational sector and flight and aviation operations. These are some of our workshops. It's another donated aircraft by the armed forces who send their students here then to operate. So these are some of our students. Building and construction, this is another important department. Of course, as you well know, Malta, the construction sector is quite something which is quite important. If you have a look around, you'll see a lot of sites. We train students who work in this field, both in terms of construction, so we can say draftsmen, quantity surveyors, professional persons with a Bachelor of Science, but also we train the people who work in the building services, such as welding, fabrication, steelworks, HVAC, very important. So we have courses on heating, ventilation, and air conditioning. I'm sure that this is very important for our industrial players in Malta who need to use HVAC technology to keep their factories, their places of work at suitable temperatures. So here you're seeing some of our students conducting fabrication and welding work. We also have labs which are ancillary, such as the chemical analysis lab, which is used by various fields, because our students do not only learn the technology, but also the underlying principles of chemistry and physics and mathematics. Yeah, these are some of our students in the HVAC. Woodwork is another field, which there is a lot of need for students, but very few students taking up this field. Construction. Then we have the maritime sector. This is, of course, an important sector for Malta, which is an island state. Our, we can say our register of ships is among the largest in the world. And therefore, some of our youngsters, let's put it that way, it could be more, but we always strive to increase the numbers, but some of our youngsters aim to go for a career at sea. So our training involves the two aspects of training at sea, either the deck means the navigation of the ship and the operations of the ship. So one can start here at MCAST from the lowest level, the deckhand, up to the master mariner, the captain of the ship. But also have courses also on the engineering of the ship. So the operation of the engine room, the facilities, the electrical systems, etc. And we also operate simulators to train our students. And we have now opened the top floor of our institute, which will be, I can show you from here, basically. So this is our newest building. For the institute, we have 6 buildings actually, but this is the newest one. And the top floor, which would be the floor over here, that's our maritime center. We have a nice view of the port also, keeping up with the maritime field. Then we also offer courses very important for industry in terms of logistics, where we offer level 4 and level 5 programs. Level 5 is even online, delivered online. So again, students who are professional workers at industry can upskill themselves for a full level 5 qualification from their home, basically, through an online distance learning qualification. Malta being an island, again, logistics are very important for all sectors of industry. So no industry can occur, both the tourism or the manufacturing, without having transportation from abroad, both human and also material. Specialized courses, as I mentioned, so we can, apart from the courses I mentioned before, we have 60 full-time prospectus courses, for example, and around 200 part-time ones. We also can design tailor-made courses for industrial players. So many companies contact us and we design the courses for their needs, both at all levels actually. So we can go at each level and design the courses required at each level. Multidisciplinary courses, as I mentioned, becoming much more important. It's just a structure of the institute stuff. And these are some further photos of our institute, of students. I'm seeing some girls here working. An important area for us is to increase the number of female students taking up engineering. it's good that there were 2 female students speaking also before me. So because we're seeing, especially at the technical levels, many more males taking up this field rather than females, which is a pity because technology today has become an interesting and exciting area where people can work and with a profitable career. Further labs and workshops. This is a project we had launched some 4 years ago, which we have to now take on again and go for the second generation of it, where we have launched offshore photovoltaics, through which we can now look into, for example, production of hydrogen and other areas of interest. So this is basically my presentation. Of course, anyone who is interested to collaborate further with our institute, please get in touch. It's our reason that's why we're here. That's why we're here, to collaborate with you and give better training products to our students. Thank you.
Thank you, Mr. Samut. It seems there's actually a much wider range of opportunity than one would have imagined, directly relevant to all members of the Malta Chamber of Commerce. And also, it's interesting to see that it's not just, of course, students, but also your lecturers who are also in positions to collaborate.
Exactly.
So thank you. I'll make sure that the information is circulated.
Yes, please.
Thank you to all the participants here today. The video will be uploaded to YouTube and I will share it with everyone. So of course, the material can be reused and shared as necessary. I will send you the link, Mr. Samut.
Thank you very much.
Thank you. Thank you, everyone, and wishing you an excellent day. Actually, wait, I should hand over to Engineer Buttigieg for some final words.
Hello, hi. First of all, I thank all the speakers for their excellent work done, and I wish them all good luck for their upcoming tasks. So we're closing up our, let's call them almost monthly sessions. They've been, I think, really 2 good years. There are a number of topics which we handled, and we're closing up with education. Education, which I think everybody can agree is essential for the country to move forward and continue to move forward and progress. As education is part of our, I'll say, our aim as an agency. Also, we try to educate as much as possible regarding the use of energy and water, but also we have to support as much as possible the educational sector in approaching the industry, because it's the industry and the service sector that drive Malta forward. We've seen it today, we've seen it in a number of presentations, we've seen how the educational facilities in Malta have improved these past years, continued upon the progress done years ago. That's all I have to say. I thank everyone. I thank all the team of WeMake and Mary Gregg from our end, and Timothy Yolden from the Malta Business Bureau. I thank the Chamber for their continuous support. We'll see you hopefully in a fortnight. We'll be holding the final event of the WeMake program, which will be like an international online conference. We'll be trying to show a number of upcoming technologies and upcoming new best practices. So that's it, I think, from my end. I wish everybody a good day. See you soon in a fortnight. Thank you very much.
Thank you, Charles. Thank you, Ruben, and thank you, everyone.
Well done.